My name is Emmanuel, and I'll be giving you a quick walkthrough of how to use the DeepLabCut software. So if you're on the Linux machine, first you're going to want to have your terminal open. So if you go to the side, click this. This is the terminal. And I'm just going to have this file folder up here so we can just see where the files and sessions are going. So to start off, there's two commands that you're going to want to run on this machine. First is conda activate DLC Ubuntu GPU. So they should be saved here, but if not, this is the command. Just make sure that you have space and a dash. You're just going to hit enter. And so now we're going to switch over to the actual DLC GPU. So you know you're basically in that shelf. Once that pops up, from there, we're just going to type IPython, which basically gives us Python to use within the terminal. Hit that, and Python is now running. Now we can actually get to DeepLabCut because we're going to use the DeepLabCut GPU, sorry, the DeepLabCut GUI that they provided for us. You can use DeepLabCut directly through the terminal itself or with the Jupyter Notebook, but I think the GUI that they've developed is pretty easy and straightforward. Plus, that's the only one I know how to use. So we're going to import DeepLabCut. Give it about a second. Cool. Now we're going to enter this command, deeplabcut.launch underscore DLC. This will open up the GUI for us to use. Cool. So this is the main DeepLabCut page. You have just these two tabs, but they're going to be populated with tabs in a second. So we'll click here to manage product. So this video will be if you're starting completely from scratch. In a second iteration, I'll show what you will do once you have your project up and off the ground and you want to improve upon your training. So here, make sure create new project is checked, and we're going to write the name of the project. So this is going to be called testing DLC for DeepLabCut. Enter the name of the experimenter, your name. I won't be like that. I'll just put my name, manual. Then we're going to click add videos to project. So depending on what MP4 file that you've downloaded, you'll know where your video of interest is downloaded. I just have it here. Oh, here, desktop. And I've just called this bald eagle soaring. So this is going to be our example video. It can be anywhere, just know where it is. Once you see that total one video selected, you know it's there. You can do multiple videos at a time. But for now, we're just doing this with one video. You can change where you want the directory to be, where you want the project to be stored. You can also copy the specific video over to there. We don't have to worry about those now, but just know that those are an option. Once you have everything ready to go, hit OK. Cool. So we have a new project created. I'm going to click OK. Good thing you want to make sure is that you have your terminal open at all times because sometimes you won't really know that something happened in the GUI itself. But if you always go to the terminal, you'll be able to find things of interest. So we can see here a new project with the name blah, blah, blah has been created. Now we know we can move on to the next step. Now that you have your project set up and ready to go, we're going to head over to extract frames. So this portion here is just going to randomly determine how many frames it's going to select for you to physically annotate. So because DeepLabCut is a machine learning algorithm, basically you are going to train the network on a preset defined images that you're going to score. And from there, DeepLabCut itself will train on those images and then provide the best network to estimate the rest of the poses. So we're going to take a look at the config file that was actually just created. So if I go here, I'm going to go to practice DLC, Emmanuel 2022. This is basically the folder that was just created once you created a new project. So we can see here DLC models. This is where different models will go that the algorithm has trained. Label data is what we're actually going to just create now. Training data sets, these will be created after we have labeled a data set. And videos, if we look in right now, it has the video that we chose. So we can see, nice, cool, a nice, awesome bald eagle. That will be populated later. And this is the config.yaml file. So basically, this has a lot of the settings that can be changed that will help the course of the project. So if we go here, you can see if we scored the task. Items that you want to change are body parts. So we'll backspace all these. The default that it comes as is body part one, body part two, but we're going to change this. This is an example. We'll are only going to do 4 points here. So I'll say we saw the video that we just did. So we'll do the head of the bald eagle. We will do the left wing. We'll do the right wing. And then we'll do the tail feathers. Again, the algorithm works better the more points that are trained per initial frame. But as an example, as a quick run through, we will do 4. Start and stop, you can leave as 0 and 1. Num frames to pick, this is how many frames based on the video that is going to be pulled and extracted for you to label. So I'm just going to do 10. Again, you can go as high as you want to, but just keep in mind that however many frames you pick is how many frames you're going to score. So you have 20 frames you're going to pick, and you decide these 4 images, you're scoring 80 positions. If you do 100 frames, then you have 10 different body part positions. That's going to be a lot of scoring. So just keep in mind. But the more frames that you initially pick out of the video and the more body parts that you choose, the better the algorithm is going to be and run in the logarithm. Again, this is just quick and dirty, just so you can see what you need to work with and change. But just keep that in mind. Plotting configuration, you can keep the skeleton here the same. Basically, what the skeleton does is that it will plot onto the specific video a skeleton of the body parts that you had selected connected together. So as you can see here, it will connect body part 1 to body part 2, it will connect object A to body part 3. Once you have a lot of body parts to work with, you can think of it as it needs to connect to each other point iteratively. So that'll be a lot of things to fill in. But the skeleton doesn't really help in actually how the algorithm is going to work. So this is all just for your own viewing pleasure. So you can ignore this for now. Ignore skeleton color, and everything else you can leave here. This we may want to change later. This is training evaluation when the model itself is actually being trained. But the defaults are there. Okay, batch size is 8. That's how many specific frames that it'll look at a time when it's training. Iteration is the start, and snapshot index is the last trained model that it will use as its weights. And we'll be able to see this much later on. We actually start training the model, but for now, these defaults are good. Cropping, keep everything the same here. And these have to do with the specific model itself. We're going to use a default ResNet 50. If you choose a different model, there's ResNet 100, ResNet 101. These corresponds to how many nodes the model actually has. If you decide you want a more sophisticated model, you want one with more nodes, you will have to change this beforehand. You can't retroactively go and change it, but we'll keep this as 50 for now. So now that that's out of the way, make sure you save your config file. We're going to close this for now, and we'll go back to the GUI itself. So we're gonna go, so we changed it to 10. So you have the config YAML file here, choose extraction method automatic. Do you want to use OpenCV? Yes is okay. Need user feedback, no. The algorithm, these are different types of classification systems that it's going to use. Right now, it's just going to be k-means. You'll never have to change anything like this. Specify the slider width. We will see how that can be changed later. 25 is okay. Like you'll always be able to change this specific value later. And one last thing that I did want to mention before I move on is that the in number of frames to pick, essentially the video, the way that um, this program and many other different programs like read videos that they convert the videos from seconds into frames. So I have just a 30-second video. That's about 600 frames. So I'm only picking 10 frames out of those 600 in which we're going to score. So you can see how some of these videos will kind of take a long time depending how large your video is. So that out of the way, we'll click this away and just hit OK. So you can see now it's extracting and it's doing k-means clustering. You can see that was pretty fast, but again, I only chose 10 frames and the video itself is pretty small. The k-means is gonna randomly select the 10 frames that we're going to label, but you can see now here, you can now label your frames and function label frames and we're ready to go. So go back to the GUI, click label frames, and it will automatically populate what your browse should be. But if you happen to not see the file, it's going to be the same config.yaml that we're just working with here underneath your folder. We're going to hit OK, and this window will pop up. Basically, this is where the scoring will happen. So we'll click load frames, and it will automatically default to exactly where your files are. So you don't need to worry about it. We're going to do default equals soaring and click open. Now you see this nice, beautiful eagle smack dab in your face, and we have 10 images we're going to score. So here off to the side, you can see the body parts that we specifically changed, see how they correspond to head, left wing, tail feathers. And here you can choose to adjust marker size. So this is the slider width that I was talking about before. The way you label a point is by using the using the right click on your mouse. So yeah, left click is just regular click. Left click actually places the point and it automatically cycles through to the next body part positions. So now, well, this was definitely not the left one, but let's say I labeled this wing as the head. Obviously it's wrong. You can left click and then drag the specific point to wherever you need it to be. So that's where the head is going to be. It's pretty big right now. So you can go to the adjust marker size and you can increase it, see how massive that is, but that's not really helpful. Or you can decrease it. Sometimes that's too small. And depending on what video you're doing, how fine you're trying to go, you can adjust this at will. This is going to keep it at 14 because this is just, again, quick and dirty. So left wing populated here. You can see how it changes color. So it just helps with tracking. Right wing and then tail. So this part I will speed up in the middle of the video. Da, 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 blah, blah, blah. Cool, nice. Left wing, is that the left? That's the left. Right. Here. Let's say you were trying to score individual whiskers. Well, obviously, the eagle doesn't have whisker, but you're trying to score individual tail feathers. What you can do is go down here to the zoom button, draw the window over where you want to go, and then you can label it just like so. But we're okay with this. So hit next, label. Maybe I want to zoom in on the head. Let's do that. Nice. We can make that a bit smaller. Click home to go back to the full screen. If the body part of interest isn't visible in the view, don't mark it. Just because you as the viewer knows where it is, it will mess up how DeepLabCut is actually running it. So if the head isn't there, just delete it. So now hit next, no more images. So hit save, hit quit. Do you want to label another data set? If you had multiple videos, you would, but we're okay. So hit nope. And it will exit out. From there, we will move on to create training data set. So again, here's the network that it's using. This is the ResNet 50. Again, here's the MobileNet V2, MobileNet. I never used the MobileNets. There's no reason not to. You can try things out, but I think it's all pretty much the same. Again, 101 and 152, more nodes, better, better accuracy, but again, doesn't really matter for our purposes. We're just trying to get quick numbers and figures. So you can leave it at 50, keep documentation methods default. Want to compare models? Nope. And hit OK. You can see here, you'll get a message on the terminal. It'll tell you your training data set is successfully created. Good job. Now we'll move on to the train network. Again, the .yaml file is automatically populated. So here is where the significant training is going to happen. Before we actually train our network, and this is the part that will be time consuming because again, depending on the video, how much you decided to score, this could take quite a while. But before we do that, we actually want to help ourselves and help optimize the model itself. So we're going to go to DLC models. Iteration 0 is the first iteration. This is the first training session. Go to training set, shuffle 1, and then go to train. And inside of train, you'll see a pose underscore cfg.yaml file. So we'll open this. So this will basically be your troubleshooting screen. Sometimes the system can run out of memory as it's trying to process it because there's so many frames of video that it's trying to handle. If it's a large video, it's trying to read every single pixel of every single frame. Sometimes, so these tensors that they develop can get pretty large. So some things we can do to help optimize and help the system go is just clip the model in different places to try and get it to run. So if we open this pose underscore CF YAML file, we have the joint indexes, we have the actual joint names, which is what we labeled it. We have the crop ratio. So the crop ratio is the portion of the actual frame that it's going to crop then feed into the system. So it's a 40% crop ratio. We're actually going to change it to 0.8. Why we changed it to 0.8? I found something online that says this is helpful and it helped fix the errors. So can't give you a better explanation than that. In global scale, we're going to drop that to 0.4. Max input size, we're going to change this to 2400. And then min input size, you're going to 1350. So max input size, 2400, min input size, 1350. And this is the size of each frame. So each frame has a width and a height in pixels. This is what we're changing the default to. And everything else you can keep the same. Make sure you save, close out of your pose file. Now we're going to go and set our parameters to train the network. So maximum iterations is how many iterations this cycle is going to go through. So what the machine learning algorithm is going to do is that it's going to train the entire video through the network. And once it goes through, again, we're using resonant 50. So once it goes through all 50 nodes, it's going to get an output, which is basically the score that the computer gives itself based on how it estimated the entire rest of the video. What it's using is the 10 individual frames that we ourselves label. And through the training, it gets better and better. What happens in each iteration is that once it gives itself its score, through this process of gradient descent, it's going to try and find a way to minimize its error. So there's a bunch of stuff inside. Again, I don't know what's happening. I don't know what it's doing. This is a great system that has been built by others, not me. But through each iteration, the cost or the error is going to decrease each time. And the more iterations you do, the better it performs, which means the lower the error becomes. And there becomes a point where the error plateaus, where you've essentially reached the valley of what your error can reach. And so you'll have really high iterations. So as you see right now, the default is 1 million iterations. So that's how many cycles this will run. You don't need nearly that many. We're not going to be that picky about it because you'll be able to get great values as long as you're scoring really well. The thing to know about this is that yes, the software is so amazing, but if you score really well in the beginning, you really help the system a lot. So we'll do 1,000 iterations because I want this to be quick so we can see what's going on. Save iterations is how many iterations will be saved. Oh, that doesn't even make sense. Save iterations is how many iterations of the model will be saved. So at each iteration, the model has been updated with new weights to be able to train the cycle again. And these new weights are how much better the system got at performing and scoring this task. We don't want to score all 1,000 iterations, but we can save every 100 iterations. So the iteration at 100, its performance at 100 should be better at its performance at 0. 200 should be better than 100, and so on and so forth. So that when you're done with the initial training, let's say that you want to train it again, you want to rescore again, but you don't want to start all the way from scratch. We can go back to a previous version of the model. So that's what the save iteration is going to do. So we'll just save it every 100. Doesn't really matter. Probably a good save iteration is 10% of what you chose as your maximum iteration. And then display iterations. I like this. I like to keep it low so I know that it's actually doing something on the display terminal. But we'll say every 100, it will show a quick message in the terminal, this right here, and it will literally say iteration 100, iteration 200. And it's just quick, so it's nice to just see how fast it's working or how slow, depending on what you're doing. So we'll keep it at 100 and number of snapshots to keep. The snapshots again are what the model will be called afterwards. So only keep 5 and they'll distribute the 5 snapshots evenly against your maximum iteration. So want to edit pose? Nope, we'll leave this the same. Again, we already edited the pose.yaml file. We just did that. Um, if you click yes here, it'll make you edit it here within the terminal. Don't do that, just edit it here in this file folder. I'm gonna hit OK. Now should be working. You can see here, it's loading the network, starting to train. Looks like we have an error, of course. That's so beautiful. We're gonna see what's going on. Maybe because who's I can't have that much memory out here. Maybe bytes open. Let's see. Let's clear. Close this. Open this. Cool. 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 We're gonna try it again. ResNet. Aborted core dumped. Oh my God. You're joking, right? Um, DLC. Huh. What's going on? That's what I want to know. Cool. Okay. Let's open another. Okay. See what's going on. Now, I'm trying to run this. Starting training. Cool. So that worked. Don't know what happened. Literally don't even know what I did. Literally can't tell you what's happening. But now everything is working. Again, if you have some type of memory error or it's trying to quit out on you, again, like you had a core dump or what is this, you get this error, internal error, CUDNN launch failure. Just try and close every window that you have open. Make sure MATLAB isn't open. I had a MATLAB um, session open that had a lot of files and the data was pretty big and I just closed it and that seemed to run it. So if you have a memory problem, usually the information that's here in the config file should be enough to help the system. If not, then there's probably something going on where you have too many files open, you just need to close it. And you can kind of see the progress of what's happening if you open up a different terminal session and type in Nvidia SMI. Um, Once you click this and enter, it'll show you again 94% GPU usage. You'll be able to see the memory in use. So you'll see something like this here. You can always run this to figure out what you might have open that's hogging up so much memory. But again, we should be here. Now, if you can see here, the iterations again are popping up and displaying, and you can see here how the snapshots that we said to keep um, are coming. So it comes up with a new snapshot. It's saved at every 100 iterations. So you can see 100, 111. Once we reach 112, you'll see how that snapshot is displayed, but we only want to keep five. So we just keep the most recent five and the previous one is deleted. And you can see the loss, which is in that cost function I was talking about before, that's telling us how well the system is performing. You can see how it's getting lower and lower and lower over time. And we have nearly reached the end. Here we go. The network is now trained and ready to evaluate. Use the function evaluate network to evaluate the network. Awesome. Cool. We're ready to go. So we're going to go here, evaluate network. Want to plot predictions, hit yes, compare all the body parts. Yes is fine. I'm going to hit OK. You can see here, initializing, and now it's basically going to evaluate how everything performed. Usually this might take a while, but again, we have a pretty quick, easy video. Network is evaluated, the results are stored, and you're ready to go. I'm gonna click here, and you can see all the current snapshots, the log of events. If we go out of DOC models, see the evaluation results. Nice, just gives us what happened. Also, you just saved in a .csv or .h5 file. Everything we'll want will be in a .csv. It's more than fine. Moving on, go to label data. Again, before that was empty, but now again, it has the images that we labeled ourselves. It was the selected images. It doesn't actually have our scoring, but you can see these are clearly what we labeled. Those are the data sets. Cool. Now that we have that, we are going to move to analyze the videos. So there's sort of a lot going on the screen. You're going to want to first click select videos analyze. So we'll again go to the video folder that we're using. That's the one we're going to use. You see total one video selected. You would choose all the videos that you had decided at the beginning of the project. .avi is fine. Keep specify the shuffle training set index. It's basically going to use the current one that we have. Don't worry about the destination folder unless you have a specific folder in mind for yourself. I don't usually like messing with these things because wherever it goes, I feel like it knows where it needs to go and I'll just find it. I don't want to put things in the wrong path and have to worry about digging it, putting in the right path later. Save results as CSV. Yes, this is very important because the body part positions that we want slash need are going to be here. So yes, filter the position. Sure, why not? Plot the trajectories. Yeah, we can see them later. Yes, I would like to create a labeled video so I know how the scoring went. Dynamically crop body parts. No, don't worry about it. Do you want to crop the videos? No, don't worry about it. I kind of don't relatively trust the cropping. Maybe I just haven't figured out how to use it, but I wrote a little MATLAB script that can just crop your videos beforehand and feed into the system. We don't even need to worry about anything like this. Include the skeleton in the video. No, because we didn't worry about the skeleton, but if you had felt like that was something you had wanted to see, you would click yes. But again, that would have needed to have been changed in the config file from before. So we will have everything ready to go and we can hit run. Now you can see here, again, all info will be in a terminal, just to let you know what's going on. We're gonna start to extract posture. And you can see it's based in frames. And again, this video is pretty small, so it'll be pretty quick, but for longer videos, more scoring, it'll take longer. So just keep those things in mind. You know that, take a quick look here. Now here in the, oh, we can't click on it now. When we had looked at, I want to say in evaluate or in the train network, um, we only did about 2,000 iterations. Something like 25,000 iterations could maybe take 3 to 4 hours. So it's good to just keep in mind, depending on if you have something quick you want to do, or maybe you're trying to time how you want to do something else, depending on how you score this. So just keep that in mind. Cool. So now we're done. Plots were created. It says, please check the directory plot poses. And if we go here underneath videos, we see we do have a new folder, plot poses. At first, only this video is here. Now we have all this nice, interesting data here. So here in our CSV and in our filtered CSV file, this is what I'll use because we checked filter CSV earlier. Let's cleans it up a little bit more. This is a .csv file. Let's take a look at this first. This is what you can use to put into MATLAB or R or Python, whatever you're using to analyze your videos afterwards. The physical data is here. And here we have the frames of the video. So this should be what, 690, 630? Yeah, so 630 frames. So each row corresponds to a specific frame of the video, frame one, frame two, etc. And then we have the X position and the Y position of each specific body part. So here you can see that this is the head. Here you can see this is the wing. This is the X and Y positions of what was scored. And what we have right here is the likelihood estimate that that body point position is where it's supposed to be. So again, this is what was scored by the algorithm itself, but this is the estimate of its position. This is pretty remarkably low. I mean, we have like 25%, 26%. But again, it was very quick and dirty, gave it only 4 points to use. So I knew that this was going to be pretty low. But this is just so you can see what happens, what we'll pull up later. They'll do that for every position so you can, read CSV and have each column extracted. You can just dump this in a table, dump this in a cell, dump this in a struct, whatever floats your boat. Yeah, so that's there. And you can actually see the video itself. So this bald eagle ResNet 50, this is the labeled video. So if we can see here, this is how it performed. Um, you can tell me what you think. Nice, beautiful eagle soaring here. Again, more points will help it. More training will help it. But again, keep saying, and again, the better you score, the better the algorithm will perform. No, we want to believe that every program we have will be a fix-all for everything, but nothing beats manual scoring. So again, if I had minimized these point positions onto individual feathers onto a beak and maybe had more points, scoring would be a lot better. So excited this. That was just the test run. So once you have that, you're pretty much good to go. You have your video, you have it analyzed. You can go back and retrain again and try and make it better. So the next thing we'll do is make it better. We're going to go here and go through and click outlier frames. So here's a config file. We're going to select video to analyze. We're going to be this bald eagle soaring. Cool. And we're going to hit OK. So right here, I'm at the jump down 396 putative outlier frames. So there's a lot. If this list is very large, please consider changing the parameters. Use a different method. It's gonna hit yes. Now it's extracting all these frames. If it makes me score all 360 frames, that's definitely not going to happen. Um, I think the default should still be the 10 that I had chosen before, but we can obviously see here. 7, 8, 9. Yep, it is 10. So again, the number of frames that will extract will still be the number of frames that were in your original config-YAML file. 10, not the same, but different ones. So click here, refine labels, click browse, have the YAML file need, okay. Click OK. Click load labels. Once this window pops up, bald eagle scoring. Video, click open. This is the machine labels. This .h file is what it's going to use. And you get user instructions of what you need to do. You can read this. You can left click or drag to move the points. Hover your mouse to see the labels and the specific likelihood for their labels. You can right click on a point to remove it, but you cannot undo it. So be very, very careful. I mean, click on the zoom. If things were okay where they are, you can just leave them. So let's do it. Set the likelihood threshold. Let's keep it at 0.1. And we'll change this ourselves. So there's the head. It said things were all the way out here. So this was the left wing. This was the tail feathers. Was there. This was the left wing here. This was the right wing here. Cool. And then we just move on to the next one. This is the head. This stays the same. This is the tail feathers. I'll go here. Click next. This is the left wing. This is the right wing. Goes here. Left wing goes here. Head stays. Tail feathers go down. Go to the next one. Feathers go down. Right wing goes here. Feathers down here. Next. So feathers are good there. Right wing. Left wing goes here. On to the next one. That is fine there. This was the right wing. Left wing is good right there. Tail feathers are okay. Go next. Tail feathers okay. Left wing. Right wing goes here. Right wing goes here. Tail feathers are okay. Move. The head goes here. Tail feathers go here. And next. Cool, look at that. That was nice. Did pretty good there. Next. Next. And then you're done. So we're going to hit save. File saved. You want to find another file. If you had more, you would. We're okay. So nope. Quit out of this. Are you sure? Yes, we've already saved. And now make sure you hit merge dataset. Very important. Here, find all labels. Are you ready to merge? Yes. Now that we've done that, we can go ahead and train the network. But we will train the network by creating a new data set. Apologize. I'm going to create this new data set with what we have here. So you're going to click OK. Cool, the data set is successfully created. Now we can start training because we need to create a new data set with the new figures that we just rescored. Now we want to train the data set, but we don't want to train it from the very beginning again. That would kind of be counterintuitive. We want to use the network and the weights that we had built up before. So what we're going to do is first go to iteration 1, the new train. This is our pose file. This is the next iteration. So iteration 0 was the first one we did. Iteration 1 is the next one. So you're going to go to the one from before. Then what we're also going to open is if we go all the way back, we're going to go to evaluation results. We're going to go to the evaluation results from the first iteration, which is what we just run. Psych, we're not going there. We're going to go to training data sets, and we're going to go to iteration 0. We're not going there either. We're going to go to DLC models. We're going to go to the very first iteration. We're going to go to train, and we're going to take our snapshot. So what you're going to want to do, what we're going to do, we're going to want to change this initial weights here. As you can see here, this is the pre-trained network. What we want to use is the weights of the network that we just trained. So the last iteration was iteration 2000. So what we're going to do is we're going to copy the snapshot. We're going to delete this initial weights. We're going to paste this right here. And we're going to delete all the way up until 2000. So now this should read like this. Basically, this is the weights of what we just trained. Since this is the new .yaml file, we're going to make sure that we update crop ratio to 0.4. Yeah, we're going to change global scale 0.8. Sorry, we're going to update crop ratio to 0.4. We're going to change crop ratio to 0.8. We're going to change global scale to 0.4. We're going to change max input size to 2400, min input size to 1350, and we are all good and ready to go. Once that has all been changed, make sure you save, X out of it. Now we can go to train network. We'll do another 2000 iterations. Again, display 10, save 100, and we'll hit OK. And you can see here the difference is already loading already trained ResNet DLC with backbone. So already trained, that's what we wanted. Oh, excellent, excellent. Now that you have your network trained and evaluated, we can evaluate the network. Want to plot post prediction, DS, compare our body parts. We are good to go. Hit OK and initiate. Nice, we're ready to go. We're done evaluating. Okay. Analyze videos. So we have one video selected. Again, that's the same video from before. So you don't need to change anything here. Save results, yes. And these settings should stay the same, but just make sure and double check. You definitely want to create a label video. You want to filter them. No need to crop body parts. No need to crop the videos. We don't have a skeleton, and we do want to save our results as a CSV because these is what we're going to use later. Hit run, and then be analyzing now. Plots created. Oh, sorry, they should do this. Bald eagle soaring. Plots created. It says plots created, but I doubt that's this video. Yeah, these are the old ones. Make sure that training index is changed to 1 now. Okay. No, that's not what's happening. List index out of range. Fine. Nope. Fine. Fine. Nope. So we want to call it something else. We're going to change this. Rename. Old filtered. Rename. Old eagle. Cool. See here. Nice. Feel like a full. What happened also earlier is that if you're going to reanalyze the videos, make sure you delete the files that were here before so that it can make new ones. Just literally delete everything because I don't need it anymore. Now you have to create something new. Nice. This should be much better. Look at that. Sort of staying the same. Yeah, they're bouncing around, but look, we're gonna coast over and it's looking pretty good for just 5 minutes of training. Cool. So now that that's done, exit out of that, we can take a look at the CSV file again. These are the new positions. I would say the estimates got better. Some of them are coming up into, you can look at this 60s and 50s, 60s and 50s, much better. I would say that's much better. Some of these are not so much, but that was to be expected. If we go to the latter half of the video, 50, 30, you win some, you lose some. Look at that. Back, we're up to 80s now. So the more you train, the better you score, the better results you will get. And from there, looks like we are completely done. We got all the poses we wanted. And thank you for watching this video. Again,